Assalamu alaikum. My name is Saida Abida Zara Naqvi, roll number 21 TE111. Today I will discuss about Lab 6, DFT Properties and FFT. The objective of this lab is to representation of discrete time digital signals into frequency domain with respect to FFT, resolution of spectrum, computation of magnitude, phase and power spectrum leaking and avoiding spectrum leaking. Task 1. This MATLAB code performs digital decimation, computes the discrete Fourier transform DFT for even and odd samples separately, merges them, and finally reconstructs the original signal using inverse fast Fourier transform IFFT. The signal x is equals to 1, 2, 3, 4, 5, 6, 7, 8 is decimated by a factor of 2, separating even and odd samples into XE and XO respectively. DFT is calculated for both XE and XO separately, resulting in GEFFT and GOFFT. The signals are merged back together using the provided formula, where NE and NO are the lengths of XE and XO respectively. The merged signal X is initialized as zeros and computed using the formula involving GEFFT and GOFFT. Finally, the original signal, decimated signal, and reconstructed signal are displayed using DISP function calls in the output. Moving towards task 2. This MATLAB code performs signal decimation, calculates the discrete Fourier transform DFT for even and odd samples separately, merges them using a given formula, and compares the resulting DFTs using MATLAB's built-in FFT function. The signal x1 is decimated by a factor of 2. x1 is equals to 2, 4, 2, 4, separating even and odd samples into XE and XO respectively. DFT is calculated for both XE and XO separately, resulting in GEFFT and GOFFT. The signals are merged back together using the provided formula. The merged signal X is initialized as zeros and computed using the formula based on even and odd DFTs. The original and decimated signals are displayed using DISP function calls. The DFTs of the original and decimated signals are compared with MATLAB's built-in FFT function. This is the output. First is original signal, second is decimated signal, and the last is DFT of x1. Moving towards task number 3. The MATLAB code performs signal decimation for two input signals x and y. X is equals to 1, 2, 1, 1, 2, 0, 2, 3. Y is equals to 2, 1, 0, 2, 1, 3. It calculates the discrete Fourier transform DFT for even and odd samples of both signals separately, merges them using given formulas, and compares the resulting DFTs with MATLAB's built-in FFT function. The input signals in X and Y are decimated by a factor of 2, separating even and odd samples into XE, XO, YE, and YO. DFT is calculated for even and odd samples of both signals, resulting in GEFFT, GOFFT, HEFFT, and HOFFT. The signals are merged back together using the provided formulas. The merged signals X and Y are initialized as zeros and computed using the formulas based on even and odd DFTs. The original and decimated signals are displayed using DISP function. calls. The DFTs of the original and decimated signals are compared with MATLAB's built-in FFT function. It gives output DFT of decimated X, DFT of decimated Y, and DFT of Y. Moving towards task 4. This MATLAB code computes the frequency representation of the signal X using a custom function myFFT, compares it with the result obtained from MATLAB's built-in FFT function and displays the results. The custom function myFFT is used to calculate the frequency representation of the signal X. MATLAB's built-in FFT function is also applied to the signal X to obtain its frequency representation. The results obtained from both methods are displayed using DISP function calls. Output gives this result. Now task 5. The MATLAB code computes the fast Fourier transform FFT of 4 different signals W, X, Y, and Z using a custom function myFFT and compares the result with MATLAB's built-in FFT function. Signals W, X, Y, and Z are defined. The custom function myFFT is used to calculate the FFT for each signal FW, Fx, Fy, and Fz. MATLAB's built-in FFT function is applied to each signal to obtain the standard FFT results FW STD, Fx STD, Fy STD, and Fz STD. The results from the custom function and the standard function are compared and displayed using DISP function calls. Here the output gives the results of myFFT compared with FFT, signal Y and signal Z, custom functions and the standard function.